There we go. 6.3, perform function operations and compositions and talk about something called domain, which is the bulk of what this lesson is about. Anybody know what domain is? It's not, it's X. I wish it was that easy. I'm sure there's somebody in here who's never eaten at Chick-fil-A. I'm sure that person exists. But, you know, shame on you for not having God's chicken in your life. That's all I can tell you. If you go to Chick-fil-A, your order would be considered the input. It's the X value. You know, you go to Chick-fil-A, you order number 2 spicy chicken sandwich. What do you get back? Number 2 spicy chicken sandwich, and you know, God bless you, because it's Chick-fil-A. That's how it works. So the order was the input, the output was what you wanted, right? You go to Chick-fil-A and you order a cheeseburger. What do you get back? Nothing. Nothing. Why not?
It's not
on the menu. It's not an input order, is it? It's not input. Domain is input values that have output. So it's input values, which are generally known as X, that have output, which is generally known as Y. I'm glad that you realize it's X. There's just more to it than that. It's stuff that has output. X values that have output. And there's 2 situations when you write functions where output may not exist. Just 2 situations where output may not exist. First situation deals with, can you ever divide by 0? No, it's just not possible. Okay, let's do this with some funky looking notation. So let's say that you have something, we'll just use 1, over a frowny face. Use frowny face. What do you know about the frowny face? It can't be 0. The frowny face is not 0. Most math books teach it like this. If you have A over B, B is not 0. That's just what they do. I don't know if that means anything to you. It just means the bottom is not what? No. The bottom's not 0. We've talked about this Thursday. There we go. Consider this rational function, 4 over x plus 3. Well, this introduces a fraction. We have a fraction introduces that possibility of having input that has no output. And it would happen if you tried to divide by what? 0. So what do you do with the denominator? What do you know about x plus 3? It can't be equal to 0. What can't x be? Negative 3. And I wish some kids got this, but you know, what happens if you actually tried to be a negative 3? It'd be this. This would be going to Chick-fil-A and ordering a cheeseburger. It's not going to work, is it? That's the first rule. The second rule deals with even roots. So there's an even root, square root of x. You agree it's even? All right. What's the smallest thing you can take the square root of? Let's go with cadence. Smallest thing you can take the square root of and be a real number. And you can do better than 4. You can do better than 1. Oh, let's talk about it. Square root of 4 is what? Square root of 1 is what? 0. Smallest thing you can take the square root of is a 0. The square root of 0, and that is a square root symbol, is 0. Last time shift. And 0 is a real number. All right. So here's this rule. You want to use a nice math A over B, or do you want to use frowny and smiley faces? Oh, you want to do A over B? Okay. Say you have say you have the square root of A. You can take the square root of 1 and get a 1. You can take the square root of 2 and get a 4. You can take the square root of 9 and get a 3. You could also take the square root of 0. 0. Could you have taken the square root of negative 1 and been real? There is a relationship between A and 0. 0 is the smallest thing you could evaluate. What's the relationship? Greater than or equal to. Whatever's inside that radical is greater or equal to 0. There's another extension of this rule. You make a fraction where the radical is in the denominator. It's kind of the same as the first part. You still got a relationship here about b and 0 because you care about what's in the radical. But the relationship can't have equality in it, can it? So what's left? B is greater than 0. That's the rule form. B is greater than 0. The thing that's under there is nothing. Don't worry about it. There's your rules. You got rules dividing by 0 and even roots. There's no rule for odd roots. You know why not?
Does that work? You can't on the square root of all of them.
No, odd roots. Odd root would be like a cubic root. You know, a square root has a problem with taking negatives, doesn't it? Square root of negative 64. It's not real. What's the cubic root of negative 64? Which is real. There's no rules about odd roots. It's only even roots and division of 0. It's only 2 exceptions in the range. Everything else works. All right, consider the root of 4x minus 2 and state its domain. All right, so if you look back at our form, the 4x minus 2 is the b in your forms. What do you know about 4x minus 2? B is the stuff in the radical. Well, actually, the first one is A is the stuff in the radical, right? So it's the stuff in the radical. What do you know about it? Greater or equal to 0. This wasn't a fraction. You just say it's greater than or equal to a 0. And that, boys and girls, is a 2-step equation. And I'm not going to write out both steps. What is x greater than or equal to? 1/2. Add 2 divided by 4, kids. I told you sooner or later I'd get tired of reteaching that same old thing, and I am done at teaching it. All right, there's your domain. There's 2 ways of representing domain. You can use what's called a set builder or interval. Anybody remember what set builders start off with? There's an X bar. First thing is a curly brace. Starts with a curly brace, stops with a curly brace. Do you remember how X bar is supposed to be read by someone who actually understands the math? X bar is read all values of x such that. And here's where the such that part comes in. What do we know? All values of x such that x is greater than or equal to 1/2. Interval form, when I taught interval form, what I would do is I would take our existing inequality and I'd put it on a number line. 1/2, by the way, being a solid dot greater than or equal to. And which way would you shade? Greater than or equal to, which way would you shade? Shade to the right. If you ran right forever, what concept would you eventually get to? Infinity. So when you write intervals, you're actually thinking about number lines and shading and all that. You start at 1/2, you stop at infinity. Right. Bracket on the 1/2 because brackets imply equality about infinity. Yeah, can't actually be infinity, so concept. All right, next one. 4x plus 2 over 3x minus 1. Which rule is this? Rule 1 or rule 2? Rule 1. Rule 1 cares about dividing by what? 0. If I was going to divide by 0, would it happen at 4x plus 2 or 3x minus 1? It would happen at 3x minus 1. And I'd literally say I'm not a 0. I do the 2 steps, and I have the thing that I could not be. What is the thing that I could not be? 1/3. There's no way for x to be a third. All right, set builder notation, curly braces, x bar, such that what? just not 1/3. In English, they're supposed to be teaching you to write simple and conventionally, just keep it stupid simple. The easiest way to apply the KISS principle here is just keep it simple, stupid. Keep it, you know, let's just say not 1/3, because it's understood, right? The rest of it's understood. Now, I am glad, Cadence, of what you mentioned. You mentioned that you could be less than or greater than. That has its place in interval form. It does. When you think about the interval form, you've got your 1/3, open hole, close hole. Open, no equality. Cadence mentioned that I could be less, which means that I would shade which direction? Left. She also mentioned I could be more. I could shade to the right. If I run left, where do I end up at? Negative infinity. How about if I run right? Positive infinity. See, this doesn't have one distinct interval. There's only two. You've got stuff on the left and the stuff on the right. Yeah, that's where you're right in the middle. You get to be from negative infinity to 1/3. That's the right interval. Sorry, that's the left interval. What's the right interval? 1/3 to infinity. And Gaten said, yeah, the U. Union West. And that's all the time I'm actually going to spend on writing set over an interval. It's still in your notes. It burns up time and I don't want to burn. Anybody any questions so far? Nobody ever does. Usually the only question I get all day is, can I go pee? The answer to that is always yes, for the most part. Two more of these, but again, I'm not going to waste time doing set over interval. 4x plus 3 sitting over the square root of 3x minus 7. What's the problem? Which piece of this is a problem, the numerator or the denominator? The denominator is where a problem might happen. You should know two things. Can't divide by 0, right? But you can't just say 3x minus 7 is not 0. It doesn't work that way. Think about, and you actually have this rule written down completely. You have root A over root B, or you may just have A over root B. But look at that thing that talks about A over root B. The emphasis on the root of the bottom. What are you supposed to do with that bottom piece? Make it bigger than 0. That's all there is to it. I hope you understand that. If you had the equality, you'd create a huge issue. Because if you had the equality, you'd try to take the square root of 0, function's dead. Just like that. Do your 2 steps. What's x got to be? Greater than 7/3. And again, even though it's in your notes, I'm not going to waste time doing set, build, or interval. G of x. How do I figure out its domain? Is 4x minus 2 going to be a problem? No, numerators never are unless there's a radical there. What's going to be the problem? I am not going to factor this. I'm not going to factor it because your quizzes say that as a class, even on recording, you suck at factoring. That's just me being blunt. So I'm not going to factor it. Because you don't always have to. Say it's not 0. You're not going to factor, play the isolation game. What do you want to do first? That would be 2 steps ahead. No, I'm glad you can do that. I am not going to do that in 2 steps because a lot of kids can't. Move the 121 right. That is counteracting with subtraction. And now we counteract the multiplication through division. That isolates the x squared piece. Nathan, how do you counteract square rooting? When you're dealing with fractions, at least in your head, you should view it as 2 distinct pieces. It's root of 121 over root of 9. What is root of 121? 11. What's root of 9? 2. Now this happened to a lot of kids. Parker, why did I count that wrong in the quiz? Look what I wrote. It's wrong.
Well, I didn't even.
Oh, you didn't get the right answer, never mind.
I didn't work it out.
Plus or minus matters. It is not.
Oh, that question. Yeah. I got that one right. I'm still question.
You're not positive 11/3, nor are you negative 11/3. Okay? And again, not worried about set, build, or interval, need to move on. Domain and composition. I have some funny wording up here. It says domain of a composition function is inherited from the seed. Additionally, the offspring may have its own issues. I'm talking about something we did Thursday. Thursday we did stuff like this. F of g of x. Remember doing that? That's literally where you seed function f of whatever g is. That's why I'm saying seeding. You need to think about this in second to some degree if you want, if it helps. And that kind of is the relationship here. Some of you boys are going to grow up and be spitting images of your daddy, just the way it is. You're going to have all of your daddy's issues, plus all of your own, aren't you? By and large, that's the way it works. Usually it's a combination of your parents. But usually you have all the problems your parents had. Like my mom had crooked teeth, my dad had rotten teeth. Guess what I got? Crooked rotten. Things cost me a fortune. Cost them a fortune too. Anyways, that's inherited. Domain is always inherited from the seed, which hopefully this will make sense when I do A and C. See, you don't read that fog X. How do you read that? F of G of X. And I would suggest you rewrite it F parentheses G parentheses X. If you rewrite it like that, it makes it more clear which one's the seed. Is it seed F or is it seed G? G. It's literally being inserted. It's an insertion. I talk about domain being inherited from the seed. So what you're supposed to do, although it rarely happens, is you're supposed to find the domain of 2x plus 7. That's how you're supposed to start these things. Think about any issues that this thing might have. Does it have daddy issues? Okay? 2x plus 7. If you graph that, what would it look like? A slanted line. Slanted lines go left forever, right forever. What's the domain? Negative apostrophe there. If you like set builder notation, all values of x such that x is an element of the real. You've seen that notation before. Or negative apostrophe. That means that the dad is okay with any given number. However, just because the dad is okay with it doesn't mean the child is. F of x is 2 times x to the negative first. Can anybody rewrite that so the exponent is positive? I'm not doing this for you. 2 times x to the negative first. What does it look like so if the exponent is positive? 1 over 2. 2 over x. 2 doesn't need to move. What's the understood exponent? 1. I say this a lot. Understand the understood. I know you've heard me say that, haven't you? Understand the understood. You need to understand it because you don't just yet. You do when you see it, but you got to see it. Anyways, back to this. Since g of x is 2x plus 7, everywhere I see an x, what am I going to replace it with? 2 over 2x plus 7. That's the composition of the two functions. And it's going to have a lot of data in it for domain, but it's got its own unique issues. This is a fraction. What do you worry about when you see fractions? Worry about dividing by 0. That happens if 2x plus 7 happen to equal 0, right? So 2x plus 7 cannot be 0. Two-step equation, what's the value that x can't be? All right. See, it inherited from dad the ability to be everything. But on its own right, there's one thing it couldn't be. -7/2. It got everything from dad except this one unique thing. Domain is inherited from the seed, but then you've got to look and see what happens. We're not going to do golf, we're going to do FOF. So find FOF of x. What is FOF of x? f of x. And f of x was written to be 2 over x. Now, what a student's supposed to do is they're supposed to look at functions originally and find domain, although they never do it, so I'm not going to do it on this one. If I composed f from itself, I would start writing down f of x, which is a 2, and then I would encounter an x, wouldn't I? And f of x 2 over x? What am I supposed to replace that x with? 2 over x. This is what I get. 2 divided by 2 divided by x. Clean that up. Every fifth grader knows how you divide by a fraction. To divide by a fraction, you multiply by its reciprocal. This becomes 2 over an understood 1 times x over 2. What did we have to look like? Okay, let me erase that. I was hoping you'd go a step farther. Shame on me for assuming. Becomes a 2x over a 2, which looks like x. Now, this needs to be talked about. What just happened? This is the composition. This is the simplification. It just looks prettier, doesn't it? Composition was actually the first thing you wrote. Then we simplified it to look prettier. If you look at the simplified answer, do you see a radical? Now, do you see a fraction? Hopefully what you see is a line. What's the domain of a line? Negative infinity to positive infinity. If you just look for domain in the final product, you will often miss the question. Look at the actual composition, the very first thing you did. Composition is a fraction. Fractions introduce the ability to divide by 0. What's the one thing you couldn't divide by at the point of inception when you created the function in the first place? Couldn't divide by 0. So even though this is the final product, it turns out that if you go back and you look as you were creating it, that x couldn't be a 0. You can't just look at final products. You see right here, what if x was a 0? Would it have happened? No. So you've got to look at the point of initial composition to determine domain. And depending on some of the stuff, if we get to it, you've got to look at intermediate points as you go along. Domain's the process that starts at the beginning, stops at the end. Let's see if we can do the last one before you leave. That's the last one we're going to do anyways. This is a very good problem. Given f of x is x squared minus 12 and f of x minus 3 is x squared minus kx plus z, find k and z. Anybody got a starting point? What's something you should be able to do when looking at that problem?
You can plug in x minus 3.
That's right. You can find f of x minus 3. Grace and Parker said that about the same time. You can find f of x minus 3 by letting x be x minus 3. Parker ruined this last time. Reasia, what's x minus 3 all squared? Okay, good. Square something, write it twice. Write it twice and what? Oh, quit teaching FOIL. Double distributive property. That's what it is. DD doesn't like double D's. I don't know.
Why not?
What's x minus 3 times x minus 3?
X squared minus 6x plus 9.
I don't disagree with that. No work shown, but that's a negative 3x plus 9. You know, not wrong. Put it back together, what do you get?
X squared minus 6x minus 3.
How does that help? It helps if you're a little bit intuitive. I teach this a lot throughout the course of the year. It's a lineup process. Take the original function, or take the answer, kind of, and write it right underneath it. Looks to me like K and Z line up perfectly. So you'd have negative 6x being equivalent to negative kx. And I don't know that that actually needs to be written out. But if there's a negative 6x and negative kx that line up, what's the k value? 6. Tell me the kid that says negative 6. They were both negative. So k is just 6. What's the z value? Not 3. Negative 3. Because only the addition of a negative would make a negative in the first place. So that'd be where we stop. That's it for 6-3. Tomorrow we'll do 6-4. Thursday 6-5. Friday we'll actually finish this unit. And then I guess you get 3 days off, and then you'll see me Tuesday. And Tuesday you work on your twin.